This is Martin Carlisle with EchoBack from pico2018 2018. This program we found seems to have a vulnerability. Can you get a shell and retrieve the flag? Connect on port 37857. Okay, so we'll go ahead and connect 37857. So it asks for a message, then it prints it out. Now I've downloaded a copy of that executable. I have it here in my folder. Go back, and in that there is a vuln method. That vuln method is calling system and then read and then printf, and you'll see here that there does not look like a format string gets past to printf, so that's probably my vulnerability. And then I have some calls to putS, and I've got a pseudocode version of that that's been decompiled. So it calls system to just print the message, input your message, reads into a buffer, there's the printf vulnerability, and there's putS. Now the issue here is the printf would allow us to overwrite the got entry for putS. That will be fine, but whatever I put here is going to have the constant parameter of new line, and that's not so helpful. So the hint for the problem suggests that maybe I do this more than once. So what I think I'll do for my first goal is overwrite the got entry for putS to have it point back to vuln. All right, so in order to do that, I'm going to need to know some addresses. So the address of vuln is going to be at 080485AB. Now we need to find the got entry for putS. The got entry for putS is going to be at 0804A10C. So those are going to be the things that I'm going to try to deal with. Okay. So the next thing I need to know is where on the stack I need to be. So in order to do that, I'll do this again. I'll put in what I'm looking for here is how far up the stack I need to walk to get to these queues. So 1, 2, 3, 4, 5, 6. So my 7th parameter as I walk up the stack is those queues. So this string was stored on the stack. By using the format string vulnerability, these %x's just walk up the stack, printing out things as hexadecimal numbers, and there are my queues at the 7th parameter. Now what I'll do is I'm going to use the %n parameter to allow me to change addresses of memory. Okay. And I want to change the address where my got entry was, and that was at 0804A01C, and I want to change that to point to the address of vuln. And my address of vuln was, let's look that up again. At 080485AB. All right, and I'm going to do this in Python to make my life a little bit easier. I'll use pwn tools, and I'm going to connect to this machine on port 37857. Receive until I see that word message, because it asks me what my message is. And I'm going to send something. Now what I'm going to send is I need to send the address that I want to write to, and I'm going to write it 1 byte at a time. All right, now those are the 4-byte locations in little endian order for the address that I want to overwrite. And the reason I haven't put them in order, so you'll note I did this 1D, 1C, 1E, 1F as opposed to just doing C, D, E, F, is because the numbers that I'm going to want to write are going to be increasing in that order. So again, take note of the fact that the address I want to write is 080485AB, and I'm going to write it as 85, then AB, then 04, and then 08. Writing a byte at a time, I'm not really going to write 4 and 8. I'm going to write 256 plus 4 and 256 plus A, and let the writing 1 byte at a time trim off those 256s. So the first number I need to write is at location D, and it's 85 in hex. So to get to 85 in hex, the %n writes to memory the number of characters written so far. This is 16 of them right there. And so I'm going to add another 117 characters. And now I'm going to write to that location 1D. So 117 plus 16 is 133. And 133 is that 85 in hex. So that's going to write to the location 0804A01D, that byte, the 85 that I need. Then in order to get to the next byte, which was the AB, I'm going to need to have more characters that have been printed, specifically a number 38 more of them. And then we can write out that AB into the 1C location. Now I need the 04 in the 1E location. So to get up to 04, which is really going to be 260, to take the number of characters that I've written so far up to 260, I need another 89. And then I need 4 more characters to get from the 04 to the 08, 260, 264. So just 1, 2, 3, 4. And I'm going to use this p.interactive to just sort of see how I've done. Now what I hope will happen here is that I've caused it to, when it gets to this putS, instead of calling putS, call vuln again and just start over. And you'll see that that's exactly what's going on. I input a message, it goes back around, it lets me input another message as many times as I want. So that's great. So now I can repeat this problem over and over again. Now, on the second time, what I'm going to do is I'm going to replace the entry for printf. I'm going to replace the entry for printf with a call to system, and I have the address of system. And what that's going to enable me to do is have whatever thing I typed in get passed to system and run as a command. So that should be enabling me to do whatever I want. So I'll go back here. I'm going to do another one of these send lines. And here I need to have the GOT address for printf. And so that will be 0804A010. So that will be the address for printf. And I want to write to that the address of system, which will be 08048460. So I'm going to write 08048460 into the GOT entry for printf, which was at 0804A010. So I'm going to do the same thing again. So those are the 4 bytes that I need to write to. I know that the 7th parameter will be this on the stack. And so here the bytes in order that I wish to write, I can just write them in increasing order. That will work fine because of the way the address is worked out. And I need to have a 96 be the first byte that I am writing. And so I'm going to add 80 more characters to the 16 I have so far. Right, so that's the address I'm writing to, and this is what I'm writing. So 6 times 16 is 96. I'm going to write this 96. Then I'm going to write 24 hex plus that. Again, I'll do the same thing to loop around to get to 260 and 264. Okay, so we've written the 96. We need to get to the next value. That's going to be 36 more this time. And then 128 more to get to the 260. And then again, the 4 more to get to the 264. Okay, so that did not work out, so I probably typed something wrong there. Let's see, 10, A08408, 11, A00408, 12, A00408. Ah, so you'll see I have a 12 there. That was supposed to be a 13. And there is my flag. Format strings are extra dangerous.